Hello, I'm Stefan. Who is new to Rust Zürichsee? Couple people, 2, 3, 4. Yes. Hello, welcome. We usually do the talks in English, but lots of people speak German, so just try it. We started the Verein in 2017 for Rust Fest in Zurich in 2017, and we're doing another one in 2024. It has been some years, but it has been good. We have been keeping the community together with the meetups and went to other conferences. And today I will present a quick experiment. That wasn't me. Was that me? Is this on? Some microphone is on. Maybe it shuts off now. Okay, anyways. Ceph and Rust. I didn't have a catchy title, so store it in the Ceph cluster. It's the best I can come up with. This is my contact details if you want to hire me for streaming or teaching Rust. I'm a freelancer and we are currently hosted by ourselves. So if you would like to host a meetup, then come and find me or Mike afterwards. Hello, take any seat, they're not numbered. So I started with that already. So I'm about to finish my master's degree, but as things go with the university, they take time. I also maintain a couple crates. I put the ones I like the most here, the thread pool, the parseInt, sudo. parseInt has... You heard that? What? Okay. Okay, let's see. Maybe we'll cut it. So microphone mute. Yes. I don't know where this microphone is. I honestly don't. Ah. Okay. Mute the next one. Yes? Hello? Okay. We'll make some hard cuts in the final edit. Professionals here. Yeah, and the rest I told you already. If you want to save the date for Rust Fest, it will be June from the roughly 18th to the roughly 21st with like 99% certainty, but not all ink is dry yet. So yeah, no guarantees yet. We don't have the final contract for the rooms, but it's a very high chance that we're from the 18th to the 21st, if I can remember correctly. I want to be very correct with this one. And we have time. A second speaker didn't work out, so sorry for wasting this time, but June, yeah, 18th to 24th. I'm very sorry, 18th to 24th is 6 days. Yes, good that we checked. So now, what is Ceph? It's this logo, and it's an object storage. Hello, please come in. Nowadays, what isn't an object storage, right? Everything is an object storage. And what's the most famous object storage, or at least its API? S3, of course, it has an S3. So a typical cluster is 5+ machines. Each machine has at least a couple disks, and they're physically close together. They have a separate network, and then they have services that roam around the machines. And they don't specify an upper limit for the amount of machines they can handle. But it's one of these, yeah, you can store exabytes of data in the system and it will run fine. So they're very confident with that. This is my setup. Laptop has no static IP. It has one VM, 2 drives, no data safety, right? And my client is this actual machine. So yeah, as you can guess, Ceph wasn't happy. And the first time I installed it, it just crashed. So let's imagine a scenario like this. We want to serve the crab pictures. And we're so sure that these are the best crab pictures. Everyone will see them. And everyone will send us their super high resolution pictures, and we have to store them because we're the only ones with crab pictures on the planet. Like this. I told the AI to make me a cursed logo, and it tried to spell cursed. Maybe next generation. We'll see. But it had a little knot up there, so I don't know, and a crab. Okay, optional features would be nice. Like the crab, of course, lives in the cloud and in a container. Obviously. What else? Now we go to the technical part. I'm sorry. Do you want to see the good picture again? Whoops. Nice picture. And now work. So in the end, HTTP clients come in, and we have a couple different paths to our disks back here. And they're split in these three categories: SSDs and NVMe drives. I don't have for the virtual machine. For the virtual machine, it's just an HDD. The laptop has an NVMe drive, so we're somewhere in the middle. It's fine. Let's go bottom up. So two of the important services in Ceph are OSDs and monitors. And OSD is the storage daemon. That one takes full drives and just eats them as a whole. You give it a disk and it says thank you. And you start one daemon per disk, and then you have multiple daemons for all the disks on all the machines, and they store objects. And the monitors are the index daemons. They're also spread around the cluster. They have their own storage, which relies on the OSD side connection here I left out. And when you want to store or load a file, we need to talk to the monitors to figure out what's the current dynamic configuration. And then we just run the same algorithm in the librados locally on all the machines, and then just access the OSD directly and do whatever we want. So librados is an acronym for something very smart. It's basically over the network transparency. And it's a C++ library, and the Rados Gateway, CephFS, and the block device are projects written in C++ by the Ceph project. They just link it, and they're done. And there is a CFFI interface as well, and that's the one I will be using. And since everyone knows Minio, I called my little project Mid-io because it's a little bigger. And the path, as you can see, from Minio is just go into the file system. That one goes to a virtual disk and then ends up in the block driver for Ceph, and then all path down. We just skip all that in the middle. Same as if we had Nginx and CephFS. CephFS is a client application to the cluster that presents us a normal mount point. So we could also access the objects like that. Or we could use Ceph's S3 implementation that goes over the Rados gateway, then also goes through librados as well. So, and the big advantage of doing it ourselves is we have one less component at least, or three. The downside is this abstraction layer over there is also very nice. Right? We can have redundancy that we don't have to tell legacy applications. We can just put it in a virtual machine and it will just never die. So that's also nice. Then the CephFS has the advantage if we have a cluster running, we can just tell the cluster, okay, we mount this CephFS pool in that folder on all the machines, And now we can schedule all our containers on all the machines and have local paths that are always the same. So if we have a persistent storage requirement like a database, we can do it like that. And of course there's plugins for Kubernetes and whatnot. So all that is pretty cool, but we're old school today, and today we skip all of that. No cluster for the application. Our application itself is the cluster. And for something as simple as an S3 storage, you could just start it multiple times, give it the same cluster configuration, and then let it rip. Okay, questions so far? Yes.
I mean, maybe not so related to Rust, but
Mm-hmm.
why is this? I mean, Ceph S3 sounds very Ceph specific.
Yes.
So why is there a Rados gateway as intermediary piece necessary?
One of the limitations of this librados API is the object size, and it's not documented, and I don't know what it is exactly, but through trial and error I found out that it's roughly 90 megabytes. If you store a bigger object, it will just fail. So the Rados gateway has the ability to chunk up objects and have other nice features. Like you can call it for snapshots.
So it gets one big object from the Ceph S3 thing, and then it splits it up into multiple requests. Okay.
Yeah. And then the Ceph S3 can implement HTTP-specific things like ranged requests, like don't load the full file, only parts of it. And yeah, there is also the thing, the Rados gateway can filter stuff. So you can store JSON objects in the latest version and then send a filter in. So it's going towards an object database. Well, I haven't tested it. And you can probably also run that with librados. But at the end, you need to be clever with what you store and how you store it. So some metadata is standard. Like for instance, the CephFS, this one requires two pools. Right? One for the actual data and one for the metadata. And yeah, you can create as many pools as you want. So I think this architecture is pretty smart for a file system. Yeah. Yes?
Does Ceph S3 only implement the S3 part of the key value store, or is there also access rights and stuff?
All of it. Access rights, groups, regions, but no replication. It just assumes that the Ceph cluster will replicate itself somewhere. So. Okay, so I wanted to set it up on my machine, and at first I was like, okay, in worst case I set up 5 virtual machines, but then I noticed this runs on a battery, and if I start 5 virtual machines I have like half an hour instead of 4, so didn't want to do that. I'm running Debian 12 on most of my systems, including that laptop, so of course the virtual machine was Debian 12 as well. Installed it and then learned, oh, it's not supported. Whoops. But it ran in Podman containers, which is also not fully supported, as I learned. And it broke itself after the virtual machine reboot, not even the physical machine, like the virtual one. But good news, I lost no data because it wanted to deploy to 3 machines, and it had only 1. So it just didn't deploy and didn't store anything. All my store commands were just hanging. So, yeah. After fighting it for a day, I gave up and just went with the supported operating system. Ubuntu is currently harassing me to upgrade to the next LTS version, but that would obviously break the Ceph installation. So if you do that, there is a flag in Ubuntu where you can tell it to not ask you all the time to upgrade to the next release. I recommend that. The second point is a little bit confusing maybe. I installed it with distro packages, but not from Ubuntu itself. So I still used Ceph admin and then told it, hey, add the Ceph repositories for that version, and then installed these over Debian packages. Just know there is 3 ways to install it, roughly. The easiest one is with the distribution. You just tell apt or yum install Ceph. That works, and then you just hope the update never hits you in an unexpected way. The second one is with Ceph add-on like that you tell it to add this specific version repository, and then you won't have any surprises because you have to manually tell it, okay, now we change the whole cluster to that version. And the third one is with the new Ceph add-on with containers. But as I said, Podman is like, so you still have to install Docker first manually. And then you have the weird thing that you run a Debian-based system on the outside, and on the inside you have CentOS containers, which is just weird, but it works. Plus, you shouldn't touch it anyways, because you should use this admin interface. So, unlike other purely Linux systems, this one has a nice UI, which you can use for like, I don't know, 80 or so % of stuff. But of course, running it on a single host is not covered by the web UI. It actually tries to prevent you from doing it. So let's force it. First, we need admin access. And on the Bootstrap host, on the first machine in the cluster, you can just execute the top 2 commands, and it will output you a minimal configuration. That one is needed for all access. And if I were to enable access control on the cluster, client.cluster username is the access I have. But I was lazy, so I just used admin. Admin is the root, so yeah, it works. So it's a little unexpected because it's 2 commands, but the output has to go in 1 file. So the more you know. The rest is done with the web UI, and when you do it like I did with defaults for a single host deployment, this expand cluster won't show up, which is a little annoying. But you can enter this URL yourself. Oh, by the way, the Ceph dev target is a host entry. So etc/hosts, I just made an entry for the virtual machine, assign it a static IP, of course, because Ceph cannot handle moving through the network. And there is almost an hour-long video from a Ceph expert where he tries to move the Ceph cluster's main IP. It's called monitor IP. Every client has to go through that IP. And if you have to move it, it's a lot of work. Yeah. Also, what I noticed while watching a lot of tutorials is that the first machine has just 1 tag. It's _admin. And that one is usually reserved for a machine that just controls the cluster. Ideally, you have more than 1 machine in case that 1 machine dies. But the idea is adding more machines and giving them tags. And each service type has a tag. So we have OSD tags, we have manager tags, we have MDS tags. MDS is the index service. Yeah, if you want to run it all on 1 host, you have to give this 1 host all the tags. It is what it is. And then sadly, the setup misses the MDS service. I don't know why. I think it's a little oversight, but yeah. You just add the MDS service and deploy it with the label, and then the cluster works. And after that one, you can add a pool that won't deploy because it still has the requirement of 2 hosts minimum, because Ceph is really trying to not lose data. But then we can go back into the shell and just tell it, allow pool size 1, then for 1 specific pool say minimum size 1, and then say size 1, and yes, I really mean it. And then it deploys. So, yay! Now I can write stuff and read stuff maybe, but it's looking good. And this is the final result. It's a UI with 1 manager, 1 pool, 1 storage, and this is the partition group that is clean now because I just told it, shh, no, it's okay. Yeah, and just running that, you see there is a couple hundred megabytes of occupied storage, because as soon as everything starts deploying itself, it also deploys Node Exporter and Grafana and Prometheus and starts logging itself. So the longer this runs, the more data is in the storage without having any useful stuff, because the monitoring, of course, uses Ceph itself. Okay, now let's get into this rapid prototyping I've heard so much about. I noticed during debugging, it's very annoying because, let's say, you forgot to start up the virtual machine because you rebooted your physical machine. It will just hang. Rado's library is in the opinion that the cluster is always right. So if you cannot connect to it, it will just try forever. At some point, you will move in the network and the cluster will become visible. Yeah, and if not, it just sticks forever. Lots of logging. And I think now let's go through the examples. Okay, magic strings. I started with them. Most obvious one is the user ID. After having set up the cluster more than once, I was like, okay, going through the code and changing the strings, don't do that anymore. Let's use a TOML. And it's literally these lines spread over the program. The stuff that's cut off here is the expect messages. Who uses expect instead of unwrap? Yes. Couple people. I can highly recommend it, especially because you can differentiate between read failed and parse failed, while you of course assume no one will write an invalid config, because I write invalid config, so there's no chance of me making an error. But sometimes you forget to create a file. So I started adding path checks where I was like, okay, does it exist? And because I specified the cluster config path here, so I have different configuration for a different cluster, maybe I have a typo in my config file. So I also check if the cluster config file exists. And here you see my strategy for having a nice CLI UI. First I output the error, and then I just exit with some error code I decided on. It's not the best, but it is the fastest, and yeah, I regretted that a little bit, so let's see what we can do about that. This one I told you already. If you connect to Ceph and the cluster is not up, it will just wait. So let's parse the config file. And because their ini file is not strictly standard, you would have to implement an actual parser, and I didn't want to. So I split it by line, looked for the monitor host, and then just called next on it. It's like, yeah. If not, if the monitor host is not in this file, it's invalid anyways, right? So why should I continue? And then I have this line here. So you can see standard KVM IP range. And maybe I have overlooked it. So I wrote this function. It's basically a split in between, right? So I want to split between v2 colon and /0. So, but yeah. And then, of course, all-time favorite, parse. Has anyone implemented fromstr? Yes, nice. This one generates the parse function. It's very handy if you need a quick and dirty parser for anything. And it integrates well with Cerde and others, and you can use .parse function, but it returns an error type. So we'll just transmute the result into an option, and then we can use question marks over here and be happy. Liveness check is simple. Just give it a low timeout, I think I gave it a second. Yes, I did. There it is. And then we'll just give an error because I like Easter eggs. Can you guess why I chose exit 500? Yes, yes. It's for upstream proxy is not okay for some reason. So, yeah. Okay. Let's do the work. Remember CRUD? What's the C? Create. What's the R? Read. The U? And from there the D? Delete. Yes. And now I feel good because I have reminded you of university or something. Okay. Let's go more ergonomic. And basically it's that. In the main function, I make an inner that handles the error type for the Rados result. And all the things I do is returning Rados result. And because I was lazy at that point, I just expected it. It was like, yeah, some error occurred. Here's the debug print from the error result. It's okay. Does the pool exist? Sometimes, maybe there's more than one, but we can check. So we can ask it, Rados pools, of course. What else can we do? We can write an object. It says here, hello. We can read it back, but we don't know the size of it. So we have to start with the buffer. And there's a funny thing here. The Rados object library, or the FFI library, checks the capacity of the vector for the C part, and then tells the C part, this buffer is this size. So if you construct this with just vec macro or vector new, the capacity is 0, and this will return nothing because there is no buffer allocated. Because Rust optimized that away, I don't know, 2 or 3 years ago, when we decided, yeah, we have a lot of vecs that are never used. Why should we allocate anything? We just don't. But for CFFI, we need a capacity, and 4 kilobyte is okay for a start. And of course, when you get it back, you see the U size, and we can also read the offset. So if we notice, oh, we get the full buffer back, we would have to loop. I just didn't because I know the string that's coming back is short. And if we don't use the full buffer, we have to truncate the buffer before we can read it, because the rest is undefined behavior, right? It's probably still in the same state as before, but you never know, right? Maybe the C library does weird stuff. Phew. Anyone done this read-write stuff with C? Yeah, nice. So I'm thinking of adding a little layer on top of that, because that is always the same. Any object you read and write, you have to do it. It's just annoying. So little object that can contain the connection. And of course listing is also a thing, but guess why I made this little emoji here? What is weird about this code? This is not the library code, this is my application code. So the top is getting the things, and below is iterating over them, which I think is normal. What's weird on the top one? Any ideas? Give you a hint. The pool structure is not from my code. That's from the glue code, like from the Ceph crate. You see its construction? You just create the structure, and then the context is the return value from that function, and that function returns a vector of void pointers. I mean, it works, yes, but it's weird. I have a pull request that I will post to them probably tomorrow, because I want to have this Rados list pool objects return an iterator, aka this pool structure, and not a vector of void pointers. It's just, It's not the Rust way. I feel like Yoda. It's not the way. Okay, so we speed ran through it. We didn't cross any of the other paths. We just went straight down to the middle. Do you want to see a little demo? Okay, okay. Let's see. This is the shell. Oh, actually, it's the wrong shell. So, cargo run release, not that much. Okay. Compiling all the things. As you can see, there's lots of stuff that is more for our benefit, like term color. And now we get into the parsing stuff and the Ceph library. And at some point, brum. So the Librados version is weird. It's always 3.0.0. I don't know why it's 3.0.0, but okay. Then we run our config check. That's the stuff I did before, like seeing if the cluster is online and whatnot. And we connect, and then we ask the cluster, hey, give us general stats, why not, right? And here we see the 20 gigabytes are available, and used are 480 megabytes. Available is, of course, the rest, and we have 3 objects stored. We can open the pool. Luckily, it's the only pool that has objects in them. We can write, and it can read it back, so yay, it worked. And here is the 3 entries. And as you can see, I tried to create a 100 megabyte thing first, but it failed. And it is actually the same size as the 90 megabyte one. So I don't know why, but it is what it is. And the cool thing here is, in the storage layer, we have namespaces. So if I were to say, okay, I want the S3 namespaces, then I can store that in the file system as well, and then my lookups are faster because it partitions over the namespace. Of course, a hugely polluted namespace will be slower than a small one, but at least the cluster can reduce the number of search possibilities already just by using the namespace. And yeah, that's it. Any more questions? No? Cool. Yes, please.
You mentioned that the other library that uses like the S3 library doesn't care if there are multiple things. It just assumes it's like the clustering thing. And you said
you mean that one?
SFS3 doesn't
Yeah.
do the clustering thing, but that does Rust Gateway does that. So
Mm-hmm.
3 is it's your thing, right?
Yeah,
Yes.
I made it. It's the demo
Do
project.
you plan to do that at some point? I see it's just a small thing right now. But
What do you mean by clustering thing?
you said before that Rust Gateway
Mm-hmm.
does the
It does chunking and stuff like
Yeah.
that. Yeah.
So your thing does that.
Not yet, but it would have to do it. Yeah. Yeah, that's the idea. Because I think it's a little annoying to only be able to store 90 megs at the time. Kind of
Especially
defeats the...
for usage,
Yeah, well, it depends, right? I have a customer that literally does that. User uploaded pictures are all stored in S3, and the biggest one is, I think, 10 meg. So it depends, right? But you never know. It could be that at some point they decide to upload a VM image. Why not, right? But yeah, so the intense thing for me is having all the hardware that backs it, right? Because you cannot really run it on one machine or two. You should at least have 3. And then you need the storage, and just running that for fun in the cloud. Thank you. Yeah. But as a hobby project, Ceph becomes very expensive very quickly. But as a professional, you're like, okay, we have this and that, and we make that much money, then it's just tooling cost, right? So it's pretty cool. If you want something smaller, GlusterFS can do similar stuff that the Ceph FS part can do. That's how I stumbled into that project to begin with. So, yes, please.
Do you find that this is simpler than actually writing a new thing in Rust, simpler than taking video or Nginx over ZFS or the rest of it, or
No.
motivation?
No, it's not simpler, but it's more fun. And I wanted to learn how to work with Ceph. And then I tried to set it up in the beginning and tried to go the Nginx or Kubernetes over CephFS route. But I failed so badly that I got interested. I was like, why does it fail? Why can I not store stuff the way I expect to? And then in the end I learned, okay, if my thing can talk to the cluster directly, then I don't have to care about all the intermediate infrastructure. Okay. So there's pros and cons, right? If I have another application that wants to use the same cluster, then I need to be able to have an interface that application can use, which most of the time is files. Right? And as long as I don't have a virtual machine hosting machine in the cloud, then this path on the right is also blocked because it's just not efficient to have nested virtual machines. So it leaves you with these two, or the left three. And then I guess for most people, having the cluster running, if there are virtual machines, having at least a CephFS entry point is probably the best. And then you have also an abstraction over the upgrades. So if you change the version, I'm using version 17, 18 is a release candidate like stable, I don't know. It's the next thing, but I don't recommend it yet. So if you upgrade from 17 to 18, you have the chance that you have to recompile all the libraries that use the cluster directly. And if you go one of these two routes, they come shipped with the cluster and their interface is stable. So yeah, there's another good reason to not do it directly. Another a reason for doing it directly is if you have latency problems, right? It's just less systems. Like ideally, this is one system, or this is one group of systems, right? The Librados runs on every system up here in this level. So this is one system, this is another one, this is another one. So we have 3 systems that run the disks at least, and then a 4th one, or a 4th and a 5th one that run the interfaces. Right? Ideally you have, this is number 4 and these 2 run on number 5. So you have 5 systems that are just there to offer storage. And now you need a 6th one to run your application. And if that is a problem, then you can say, okay, I run it on 3 systems, then have the redundancy, and then on one of the systems itself, I can directly access the cluster. But of course, it's a little more involved, but it's fun. Yes. Please.
I have a question about Librados and this Ceph device.
Mm-hmm.
Does it abstract away these hexabytes of storage, and would that block device then appear as one device of hexabyte size?
I don't know how big you can make it. I don't think you can do exabytes. So what you can run on top of the block device driver is an iSCSI target, which you then can use as a SAN backend. I don't know what the biggest size is. It's probably around a petabyte, but I don't know. But worst case, you can just do multiple disks, right? Multiple Ceph block devices, and then just RAID 0 them together, or use LVM2 on Linux and then bunch that. But the bigger question is, what file system do you have on top of that, right? Like, imagine you have one disk that's a petabyte in size. What file system can you put on it that runs, right? It's basically ZFS, right? That's it. All the others are probably gonna work. And at that scale, you have to ask yourself, why not use one of the other paths, right? So, but yeah, good question. Cool. Any other questions, or do you want to just hang out and chat a little? There's no second talk. So the possibility to go for a beer or food, I guess. It's still early. Yeah, still early. Cool. Okay, then thanks for your attention.